today we're going to go over tektites and some pseudo-tektites and impactites as well. So to start off, a tektite is like a little silica droplet formed from the melting and rapid cooling of terrestrial rocks that have been vaporized by the high energy impacts of large meteorites, comets, or asteroids upon the surface of the Earth, according to Encyclopedia Britannica. And it comes from the Greek tektos, meaning melted or molten. So what happens here is that you could be chilling in like a desert, for example. There's sand and rock there. You see a meteor coming towards you, oh no, hits the Earth, and then turns that whole top layer into molten glass, basically, and it shoots that up into the air, and then those undergo quick cooling, fall back down to the Earth in a strewn field. The fact that they do fall into this little strewn field pattern really helps the theory that they are terrestrial based from Earth, because for a while it was debated whether those came from actual Earth or if they came from the moon, was something impacting the moon and shooting off all that glass and that falling down to Earth. But also based on the lunar missions and the samples we collected there, chemically the tektites we have are not really similar to the geology of the moon, but they are generally chemically similar to the areas where they're found. So that kind of proves that. And then how are they different than volcanic glass? Because a lot of people think they're of volcanic origin, especially some things like Saffordite, Colombianite, which are pseudo-tektites, which are probably obsidian. But they have a lower water content, lower soda, and lower potash, and they have higher lime, iron, and magnesia. So chemically they're a little different, so we can use that to sort of give us a basis. And there are over 17 actual tektites, and then, like I said, we have some pseudo-tektites, impactites. So the most popular tektite, I think, is Moldavite, and that got a lot of steam in social media in the last couple of years, but it's always been like a favorite for collectors and in the metaphysical community. So 99% of the Moldavite you find is going to be in South Bohemia. You get a little bit in Germany, Austria, and the West Czech Republic. That impact was about 15 million years ago, and it's going to be about 77.75% silica, and then you have things like aluminum, iron oxide, calcium oxide, magnesium oxide, potassium oxide, sodium oxide, and water. And so that forms this beautiful bottle green. Here is an example. I don't know if it's going to show up too well. And back, there's Paleolithic examples of like tools carved from Moldavite, which is really cool. So it's been used for a while for different purposes. My favorite tektite is going to be the Libyan Desert Glass. That is going to occur on the border of Egypt and Libya, and that was the result of an impact about 29 million years ago. And you can even see like examples of Libyan Desert Glass in King Tut's breastplate, which I think is really cool. This is going to be about 95% silica, and then you have aluminum, iron, calcium, potassium, magnesium, manganese, sodium, and titanium in there as well. This one was debated for a long time. It's still kind of debated whether it came from like an actual hit of a meteor or a hot air burst where the meteor like breaks up in the atmosphere and causes that extreme heating, but it doesn't actually make contact as a meteorite. So one of the more recent studies in 2014 came out of Notre Dame, and they were talking about using electron backscatter to figure out if there is rhyolite in there, and there are the fingerprints of rhyolite, which is indicative of an actual impact, because when you have the impact, it compresses all that zircon, there's zircon in there, into these really highly compact situations, and then that turns into rhyolite, but it's not stable at high temperature, so as it pulls it up, it's going to revert back into zircon. And so you can just see the fingerprints of the rhyolite still in the Libyan Desert Glass. And this is my piece. I really like this piece because it's like a little derringer. Next up we have Saffordite. So Saffordite is also highly debated whether it was formed by an impact or if it's just volcanic glass. I'm not convinced either way on it, but it's looking more like it's an obsidian from volcanic activity about 30 million years ago. And so that comes from Arizona, so that's fun. I've had the pleasure of collecting some myself out there. Then next we're going to talk about Colombianite. Here's a piece of Saffordite. Pretty fun. When you backlight those, they have like a nice lavender tint to them. So Colombianite is found near the Cali Impact Crater in Colombia, and that was an impact that was about 3 million years ago. And of course you have the SiO2 and aluminum, titanium. And they look like little space potatoes, which are kind of fun. So that one is definitely more likely an impactite, just because of the, it's not impactite, tektite, proximity to a crater. But there is also a lot of evidence showing that it could be volcanic origin. So that one, the jury's still out a little bit. So an impactite is when the rock is melted at the surface and it stays on the ground. It's not really in a strewn field, it's at the actual site. Such as Trinitite. Love Trinitite as a New Mexican. So that was formed completely man-made at the Trinity test site on July 16th, 1945, when they're dropping the first bomb. And so what's interesting about this is it also created a green glass over the surface where the bomb was dropped. I have a little piece here. I'm kind of scared of him because Trinitite is mildly radioactive. It was really radioactive back in 1945, but now it's got about the same amount of radioactivity as like a smoke detector, so it's not too bad, but you don't want to like eat it. And so as you would expect, you have a lot of the minerals that are in the sand. So you have SiO2, quartz, potassium feldspar, calcite, and gypsum. And then you have some other trace oxides in there. But that's like all stuff that would come from the sand. However, there are these components of heavy metal, like cobalt, chromium, lead. And where do you think those would come from? Because that's not local to the surface, but those are actually pieces of the gadget and or the blast tower. So I think that was pretty nifty. I think that might be it for today. I think I'm supposed to tell you to like this video if you've enjoyed it. And if you have questions, please don't hesitate to comment. This has been fun. Thank you.